Good evening, good morning, good afternoon, depending on what type of time of day it is for you. So today we're dealing with quality of service. And so quality of service wants to prioritize traffic. So voice over data is what we're going to do today. And then we can also prioritize voice, video, and data, and you can put them in whatever order you want. If we're looking at switch configs, so it's going to be your router on a stick config with your trunk ports, access ports, VLAN memberships, and then portfast skips the spanning tree, the 50 seconds to go through the spanning tree cycle for the switching loops. The router configs, we're going to do router on a stick, router on a stick, .1Q encapsulation. We're going to use dhcp for get IPs to the phones and the PCs. And then we'll configure telephone service, max phones, be the max phones that you can have in your environment, and a directory of numbers for virtual voice ports supported by the router. So depending on the router, you can only do maybe 100 phones or maybe 10 phones, something like that. It'll be a limitation. And then we're going to have IP source of the phone server, which is the router fast Ethernet subinterface 00.20. So let's go ahead and take a look at our topology. We're going to have a router. It's got to be a 2811, so it supports quality of service. Just a regular switch 2960, 2 phones 7960s, and then 2 PCs. So let's look at our config. So on the switch, host name, we're creating VLANs. We're going to do a trunk port on gigabit 01, which goes to the router. And then if you look at where the devices are plugged in, so gigabit 2.1. We're not using gigabit 1.1, but we can. That's for your extra phone if you want to do that later. So then you have interface 2.1, which goes to this phone. So we're going to make it a membership of VLAN 10. Turn VLAN encapsulation on .1Q. And then we're going to create a VLAN for the actual host and then your VLAN for your phone. So you can see that we're going to configure 2 VLANs on each port because Cisco phones have a built-in switch. So you can plug your PC right into the phone, which is just, the built-in switch, and then it goes back into the switch. So we're going to have to use router on a stick encapsulation. So let's go ahead and, so none of this should be new. They should all be familiar to you. Let's go ahead and copy this. Config T, paste. And it's warning us about portfast. So it's always going to give that warning about portfast, so don't worry about that. All right, so let's take a look at the router. Host name, and then now we're creating dhcp. So we need 1 for data, 1 for voice over IP, VoIP. So we have a network 10.10.10 and then 10.10. 10.120, so it's 10.110 and 10.120 for your data and your voice. Then interface E0, no shutdown, that's your root interface, and then your sub interfaces need to be created with the command interface fast Ethernet 0/0.10, turn your encapsulation .1Q. The 10 represents the VLAN number, which must match on the switch and the router, and also your sub interface for VLAN 20. Yes, fast Ethernet 00.20, encapsulation .1Q, 20 for the VLAN. And notice we're putting IPs. And then the third step would be to turn on the phone. So let's just get the router and the switch communicating. We'll copy this. Go into the router, say no to initial dialog, enable, and config T, and we'll paste. I always like to go back and look where I paste it from. So there's my host name. There's my DHCP, my network default router. So I'm looking for any kind of an error. To do no shutdown, it creates these messages down here, the interface up. Once again, that's your sub interface. Another sub interface, and then finish it out. And we never did portfast on gigabit 1.0, correct? We never did switchport on this trunk. That's why it took 50 seconds. So that's the difference between portfast, spanning tree portfast on and spanning tree portfast off. Depends on whether you're going to wait the 50 seconds for the switching loops to calculate. So at this point, we look at our phone. Okay, click on one of your phones and go to the GUI. It says configuring. Okay. All right. So let's now go into. So return this telephone -service turns on telephone service. We're making a max phone of 5 and max dial 5. The IP is going to be the sub interface on the router, which was fast Ethernet 00.20, and then port number 2000. And auto assign 4 to 6 and auto assign 1 to 5. But these are like virtual ports, so we'll talk a little bit more. You don't really need to know that much about the phone stuff. We just want to get it to work and see the quality of service. And then we're defining our extensions. So a challenge today would be create a third phone if this works and plug it into, I believe, gigabits on the switch. We didn't use 1.1. So if we create the new phone, we can throw it in gigabit 1.1 and we should get it to work. All right, let's go ahead and copy this config. Now, remember the router's actually acting as the phone server. So let's hit paste. You see that this dial 1 and dial 2 change the state up. And it registered the phones. And it's registering another phone. So let's go to the phone. Now it's no longer configuring. We have an extension up here. So the kind of cool thing is you dial the other extension 54002. It's ringing out. If we go to this other phone, you can see it's ringing and we can pick up. Okay, so the telephone seems to be working, but let's take a second to look at the PC. The PC, it did get an IP from the pool, and so it looks like the phone and the PC are working. Let's go to simulation mode. Simulation mode, and let's look at what encapsulation happens with the phones here. So what I'm going to do is disconnect the phone. So it's doing DHCP, which means it's trying to get an address. So let's go ahead and let it do that. Oh, now we see a CCP. Let's click on that. See the .1 header? So that is our phone protocol running here. So we're not going to get into too much of that, but we know that that's the phone protocol. So Cisco Discovery Protocol is used for the phones. So configuring IP, fast forward time. Once it configures the IP. So what happens is it's got to go out there, it boots up, sends a broadcast out and says, hey, I need a phone server. Once it finds a server, it negotiates the process and then it actually connects. Again, we can pick up. We'll dial 54001. 5401. And you can see this phone's ringing now. All right, let's see what we can see when we call the other phone. Ah, look at our port number 2000. Wasn't that in our config? So here's our phone. Secure CDP. I'm sorry, CCP. All right, so dial the extension 54001. So you can see that is our protocol there running for the phone. We go back to simulation, get a simulation so we can actually have it call 54001, and there it is ringing. If we turn on the STP, because it's past that point. So once again, can the PCs ping each other? So let's see what the IP, oh, let's ping what, the gateway? So IP big slash all ping 10 your default gateway. Ping and then paste. Oh, so I can ping the gateway. So what's the IP on this? So it's a .1. So we should be able to ping 1. Okay, that would be what? That would be the other PC 0. Now what's the IP on the phone? So if our PCs can ping, they ping the gateway, then our phones are actually working. So now your network works. So the idea behind quality of service is to be able to send the voice traffic ahead, and that's done in the configs already. So quality of service is built in when we do telephone service. On Thursday, we're going to configure layer 3 quality of service. We're actually going to have the router do a percentage of the bandwidth to go in and out of the internet for the phone and data. So today was just dealing with quality of service, and that quality of service is already built in with the telephone service protocol. So on Thursday, we'll do the layer 3 dealing with a little bit different scenario. So that concludes how to make a router a phone server in your environment.